The U.S. Commerce Secretary Gina Raimondo recently warned NVIDIA, saying if they keep making new chips that bypass export limits to China, especially for advanced AI, the U.S. will change the rules immediately. So, what are these AI chips the U.S. is trying so hard to stop China from developing? And how are they different from old chips? Chip costs and investment keep going up. Moore's Law is slowing down, making semiconductor progress slower. With the rise of the AI boom and generative AI, and since specialized chips are more profitable than general ones, AI chips took off. AI chips started to emerge. They are quickly replacing CPUs. Major companies are rushing to release new AI chips like NVIDIA H200, AMD MI300X, Intel Gaudi 3, IBM North Pole, and SK Hynix's Sapien X330. And Apple, Samsung, and Qualcomm are also making their own plans. AI chips are custom chips made just for AI programs. They are optimized for tasks like parallel computing, lower accuracy math, and faster memory, and speeding up memory access. Compared to regular processors, AI chips handle far more data exponentially. For apps with lots of data, AI chips process information faster and better than traditional circuits. There are three main types: GPU, FPGA, and ASIC. A GPU uses a large parallel structure with many units, designed to run many tasks at once. It is specifically designed to handle multiple tasks at the same time. They are widely used in PCs, phones, and gaming devices for graphics. The chip uses a unified shading architecture. It can be used when the AI algorithm isn't finalized. They have high compatibility and are very mature commercially. And it is commercially mature. FPGA and ASIC are mainly used for AI inference. An FPGA is semi-custom hardware, and users can reprogram it repeatedly based on their needs. This solves the problem of not having enough programmable circuits, and its running efficiency is higher than a GPU. The power consumption is also relatively low compared to a CPU. But for complex or non-repetitive tasks, its efficiency drops below chips using the von Neumann structure. ASIC is a fully custom chip made for one specific program and structure. It is more customized than GPU or FPGA. It is highly specialized, so its computing power is usually higher than CPU, GPU, and FPGA. But the initial cost is high, and if the algorithm changes, the power drops greatly, requiring a redesign. As data grows and chip limits are reached, it gets harder to meet computing needs. If huge sales are expected, the cost per ASIC chip can be much lower than GPU and FPGA. That's why ASIC is being used more often for training AI models. Many investors are optimistic about ASIC's future in AI. So, are AI chips essential for AI development? The answer is yes, no doubt about it. The main reason is that AI chips train AI thousands of times faster than CPUs, and the average cost is also cheaper. This is why major chip companies are heavily investing in AI chips. Differences between AI chips and traditional chips. They differ a lot in design, architecture, and performance. We'll compare their design, architecture, power, energy use, and flexibility. Design concept. Traditional chips are for general computing, aiming for high performance, low power, and programmability. They use the von Neumann architecture, with parts like the CPU, memory, and bus. AI chips are made to speed up AI tasks, aiming for high computing power and low energy use for specific AI apps like deep learning. Architecture. Traditional chips use the general von Neumann structure, which is slow for complex AI math. AI chips use special neural network architectures like convolutional neural networks, CNN, and recurrent neural networks, RNN, to efficiently run operations like matrix math. This helps with complex AI computing. Computing power. Traditional chip power relies on the CPU, measured by clock speed and core count. Their performance is limited for AI tasks that need massive computing. AI chips use accelerators like GPUs and NPUs to give high power. They run massive parallel matrix math, boosting training and inference speed. Energy consumption. Traditional chips have high power use because their general structure wastes energy during AI tasks. AI chips have high power but low energy use because their special structure uses resources better and cuts waste. Flexibility. Traditional chips are highly programmable for various apps, but they are not very flexible for specific AI tasks. AI chips are optimized for neural networks, giving them high flexibility for AI tasks. This makes them better for complex AI computing. In summary, AI chips are specially optimized compared to traditional chips in all areas: design, power, energy, and flexibility. They perform AI tasks much better. As AI grows, AI chips will be used in more fields. Right now, AI chip development is mainly accelerating deep learning in supercomputers and machines, leading to breakthroughs in image, language, and voice recognition. Looking forward, how will AI chips change generative AI, self-driving cars, smart homes, and the IoT? We'll have to wait and see.